Hello again and welcome back to the Illumination Talks. And we're going to talk again about climate science. Yes, I know this was supposed to be a video series on revisionary theology, finding gospel events and gospel characters in the historical record, but the climate debate has sort of hijacked the media and politics and the tax system as well. So I suppose it's worth debating this topic, and I have done a lot of work on this topic as well, so I do know it very well. So let's have a look at climate once more, because the previous talk on climate data caused an amount of controversy, much as I expected actually. So let's go through some of the criticisms that have been made to see if my complaints about climate science were justified or not. So firstly, the consensus. Science is not progressed by consensus. I'm sure it's been said many times before, you've probably heard this before, that science used to have a consensus. It used to believe in the Earth-centric solar system, the spread of disease through miasma or smells, the flat Earth, of course, we had that great one, and we still do in some places, and stomach ulcers caused by acid and stress. Nearly every science consensus has been proven wrong at some point in time. And in this particular case, the actual consensus, the paper that proved this consensus, was manufactured. The paper by John Cook, I think it was, claimed that 97% of climate scientists believed in AGW, man-made global warming. But the science paper itself was flawed, deeply flawed. And I'm not going to go through it here. You can look it up on the internet or on YouTube. But there were some serious errors with this particular climate paper. And also, in addition to this, scientists who are against the consensus were dismissed and persecuted from their jobs. And you might say, I'm exaggerating here. Scientists would never be pushed out of their job because they had a different idea, would they? But it's true. Even David Bellamy, who is the UK's favourite environmentalist, was pushed out of his job at the BBC because he didn't believe in global warming. So the message was clear. If you don't go along with global warming, man-made global warming, you could lose your job or your career. And this is how governments control society. Well, they do in the West anyway. This is how they control society. If they want to stamp something out, say they wanted to stamp out gingerism, for instance, people with ginger hair. If they wanted to prevent that, they just find someone who has said something against gingers, preferably someone famous like David Bellamy, and they ridicule them or dismiss them or throw them in prison. And then they hope that everyone else keeps their head down and toes the line. That's how society is controlled in the West. And so we get in in climate science, we get these taboo subjects that we're not allowed to talk about. For instance, the media will not mention that it was 2 degrees warmer during the Holocene maximum, just 9,000 years ago. And this was 2 degrees in the intertropical zones, not 2 degrees at the poles. It was up to 5 or 6 degrees warmer in the polar regions. And we know this for many reasons. And perhaps the easiest to understand is that the Siberian taiga forest was 200 kilometers further north than it is now. And it was further north because it was warmer and the trees could grow further north than they do now. And at the same time, the Sahara Desert turned green and fertile. So contrary to what Hollywood stars may say, a warm climate is actually good for the environment. It's good for ecosystems. Warm is good, cold is bad. And also, do note that CO2 itself, not just the temperature, but CO2 itself is good for the environment. During the Jurassic and Cretaceous eras, CO2 was up to 6 times higher than it was now, 2,500 parts per million, as against about 400 parts per million at present. And during the Jurassic and Cretaceous eras, as you probably know, the flora and fauna thrived. Why? Because CO2 is a basic plant food. Without CO2, everything dies. All plants and all animals will die. So during the Jurassic and Cretaceous, there was more CO2, which allowed for larger plants and therefore larger herbivores and therefore larger carnivores. The entire dinosaur era was fueled by high CO2 concentrations. It was the CO2 that caused these animals to become so large, or enabled them to become so large. More CO2 is good, less CO2 is bad for the environment. And note that the cooling that we've had since the Holocene maximum, so the Holocene maximum was like 9,000 years ago. It was between sort of 9,000 and 7,000 years ago. That was the Holocene maximum. But the decline in temperatures since the Holocene maximum does not coincide with CO2 reductions. And here is a diagram of that. Quite the reverse. As temperature, so in this diagram, temperature is in blue and CO2 is in red. So while CO2 was rising, the temperatures were actually falling. Now, scientists will say, and you've probably heard this many times, that there is a correlation between CO2 and temperature, a direct correlation. CO2 is causing temperature rises. Well, that may be sort of true for the last 100 years or so, perhaps. But it certainly wasn't true over the last 10,000 years. You can see from here, there was no correlation. Or if there is a correlation, it was an inverse correlation. Increasing CO2 caused temperatures to decrease, not increase. And anyway, even if we do end up with a correlation, correlation does not mean causation. We've seen this before, and we will see this again later. You have to have a mechanism. You have to prove your case that the correlation involves causation. And in this case, we might have an alternative causation, because while the Holocene cooling does not coincide very well with does not coincide very well with CO2 concentrations, it does coincide very nicely with reducing obliquity. And here is that diagram. Obliquity is the tilt angle of the Earth. And of course, if the Earth is tilted more, currently it's about 24 degrees tilt angle. If it's tilted a little bit more towards the sun in the northern hemisphere in the summer, then you're going to get more warming in the northern hemisphere. And so the obliquity angle of the Earth, the tilt angle, can affect global warming. And here we see that obliquity angle is in the red and temperatures again in the blue. As obliquity was decreasing, so temperatures decreased as well. So there is a correlation here. Does not necessarily mean causation, but there is a correlation and there is a mechanism. as the tilt angle reduces, so the amount of the northern hemisphere that's presented towards the sun in the summer months is reduced, and so it can affect global temperatures. But the CNN and BBC will not mention this because probably because it may confuse the public. Here is evidence of other factors that may be involved in global warming, in the control of surface temperatures, not simply CO2. And that may confuse the public, so it's much better if you just don't mention this at all. And we're going to talk about obliquity in much more detail in a future talk on my peer review science paper on paleoclimatology, because both obliquity and precession are directly implicated in paleoclimatic temperatures. That's temperatures back over hundreds of thousand years, millions of years. They are directly controlling, in some respects, the temperature, surface temperature of the Earth. And my paper here is quite an influential paper. We've seen this before in the last talk, but it's been downloaded 22,000 times at present, which is very high for a peer review science paper. But the media will not talk about it because it's somewhat heretical. It proposes that albedo controls paleoclimate and not CO2. So yes, it's a little bit heretical. People will ask, okay, you're talking about they, the BBC, the CNN, the scientists will not say this, they do that. Who is controlling all of this? Who is behind this conspiracy? Who is controlling the media and the politicians? Who is paying them to do this? Well, I will say there is no need to pay or coerce anyone who is a believer, a climate believer, because this is not a conspiracy. This is a bandwagon, and bandwagons are free, and this is a bandwagon of virtue, and anyone can jump on that particular bandwagon because they are saving the planet. Anyone else that doesn't jump on this bandwagon is a heretic. So this climate bandwagon works like any religion. You don't get paid to join a religion. You actually pay the church to join their particular religion. Why? Why would you do such a thing? Why would you pay money to join a bandwagon or a religion? Well, because you are the virtuous, you are the good, you are the saved. And anyone else, they are the heretics, they are the damned, they are the evil, they are to be rejected and shunned, just like David Bellamy was rejected and shunned by the BBC. So you see how these bandwagons work. They're similar to these begging adverts that you see on daytime television. They want, say, $5 a month to save something cute. Not necessarily to save the animal as such, but to burnish your reputation and your ego. So you can give $5 a month to save the donkey, or to save the kitten, and you get a free cuddly toy. Or to save the puppies, or to save the polar bears, and you get a free cuddly toy, or to save the spiders. Well, yeah, I made one of those up, I know, yes. Can you guess which one? Yeah, okay. So you can see what these are about. You can give $5 a month to become a saint with a halo the size of Manhattan. You see how these scams work, how these religions work, how these climate scams work. And so we have another criticism. from the people watching my previous video, that we have models. Climate scientists have made models, and these models prove that CO2 causes global warming. Well, no, they don't, because there is no direct proof that CO2 is causing any warming. It's a bit of a supposition, but there is no direct proof. You have a correlation, but correlation is not causation. And these models are only models. They suffer from GIGO, garbage in, garbage out. They depend on the data you put in. If you put rubbish in, you'll get rubbish back out again. And they suffer from programmer bias as well, the climate scientist bias, because the model shows you what you want to see. You choose the data, you choose the parameters that are going to affect that data, and you tweak those parameters until the results fit what you want it to fit. And in this case, they're tweaking the sensitivity, the amount of CO2 that causes an amount of warming. They are tweaking that until it fits the results that they want to give. But anyone can make a model for anything. And here's one on climate. This particular graph was made by Willis Eschenbach. Willis, we'll come across him a few times. He's a mathematician, not a climate scientist, but he's a bit of a heretic like myself and many others. But he's very good at putting together graphs of data that nobody else will look at. And so on this graph, we have the black wiggly line. That is real temperature. That's real temperature data from Hadkrut, which is one of the proper data sets that they use in climate science. And it's based on anomalies. So it's plus and minus on a mean. This is how temperatures are often displayed on graphs. And the red line that goes through it, that is the model output. Now see the fantastic fit between the model output and the basic temperature data. It's almost exact, almost exact. And the blue line, by the way, it's just a running mean. It's an average of the red plot. So, is this a proper climate model? No, it's a fake. All Eschenbach did is he took two random data sets. He took snow albedo and orbital cycles, and he tuned the data, and not very much, by the way. He tuned the data to fit the temperatures. And it fits. It fits very well. But the graph itself is not based on any particular science or any logic, and therefore it has no predictive ability. It might agree now, but it won't agree in the future. So you see how easy it is to make a false model. Although having said false, we will go through later how snow albedo may be influencing climate. So Eschenbach may have stumbled across something here. So we have these models in climate science. And in climate science, they've actually made 102 recognized climate models. But none of these models are as good as the fake one. Here is a graph of climate models versus real data. And the red plot here is the average of the 102 climate models that have been made. This is the average temperature rise predicted by the climate models. And the blue and green down the bottom is the actual satellite temperature record. And as you can see, all of the models run too hot. They tweak the climate sensitivity, that's the amount of warming that is given by a certain amount of CO2 rise. And all of them have a climate that is far too sensitive to CO2. Why? Because they want a scare story. They want to scare us with, oh, it'll be 7 degrees warmer in 20 years' time and everything will die on the Earth. That's the message they want to give. And so they tweak the sensitivity to give that huge amount of warming. But the real data is not giving that warming at all. You can see below here, the blue plot and the green plot. They are not warming half as much as the climate models. And if your model disagrees with the real world data, it is your model that is wrong. You don't tweak the real world data to make it fit your model. You scrap your model and you start again. And all of these models should be scrapped and started again. Now you might criticize this graph because it's using satellite data. And many scientists now will use surface data, the GIS or the HADCRT, surface data records, which show more warming than the satellites do. Well, yes, they might, but do we trust those surface-based temperature records? There's a good reason not to, because here is a graph of the USHCN temperature adjustments. So these are all the adjustments that have been made to the temperature data records, the data sets that they use. And these adjustments are made for many reasons, many valid reasons. There are things like the observation time of day, which was changed, and that changed the temperatures you'll get as a result. Site movements, if you change the position of your temperature measuring site. Instrument changes, they changed from thermometers to digital thermometers. That made a change. And so all of these changes have to have little slight adjustments to the data sets, to the actual temperature record. But as you can see on this graph, all of those adjustments make recent temperatures warmer. Is that justified? So if we plotted, let's for instance say that temperatures, world temperatures, have stayed exactly the same for the last 130 years, because this chart is of 130 years. So the actual temperatures stayed the same for 130 years. Well, after these adjustments, the result would be like this. So the green plot here down below is the actual measured temperatures, which we said, for instance, stay exactly the same. The red plot is the temperatures after the adjustments have been made. And you can see we get an instant hockey stick here. A 0.6 degrees temperature rise simply due to the adjustments. So when we look at the temperature rise that we see, and people show them on the graphs, the rise in temperature, in global temperature, half of that rise is due to the adjustments, not due to the temperatures themselves. And the question is, are those temperature adjustments valid? Why do those temperature adjustments always make older temperatures colder and recent temperatures warmer to give us a greater gradient of temperature rise? Surely if they were real adjustments, some should make recent temperatures warmer and some should make them cooler. And so the result might be almost no adjustment at all. But no, all of the adjustments make recent temperatures warmer. And there are other problems. Urbanization is the big one. What is known as the urban heat island effect, the effect of big cities on the temperature in the local environment. You've seen it probably on your weather forecast every day. And they will say, oh, it's going to be 2 degrees overnight. That's 2 degrees in the cities, but of course in the countryside it'll be cooler than that. It'll be 2 degrees cooler. In the countryside it might even touch freezing. Why? Because of the urban heat island effect, because the cities are warmer. Not just the temperature that we put out in our heating and our cars and everything else that's in the cities, but in the amount of insolation, the sunlight from the sun that is captured by a big city, that is not captured so easily by the rural countryside. So let's have a look at that. here is the CET. This is the Central England temperature data set, which is the longest temperature record in the world. It dates from 1659, so it goes back an awful long way. And again, this plot is plotted on anomalies, plus or minus a mean, which is a standard way of displaying temperatures. It's sometimes easier to see the temperature differences. And it shows, you can probably see on the left-hand side there, the Little Ice Age. This was back in the late 1600s, which coincides with the Maunder minimum. We'll talk about that in a minute. And then the temperature wiggles around a bit for the next few hundred years, and then look at that warming in the 20th century. It's warmed 1 degree since the 1980s. 1 degree. That's just got to be because of CO2 global warming. I mean, what else could cause it? 1 degree in just, 30 years. Amazing, isn't it? Well, not necessarily, of course. Correlation does not mean causation. Just because CO2 has risen doesn't mean that CO2 is causing the temperature rise. And there is another possibility for this temperature rise in the CET temperature data sets and the data sets from other locations around the world. Because the CET is derived from 4 different stations and they amalgamate the temperatures into one data set. Now, one of these temperature measurement stations was at Manchester International Airport, and the other was at Blackpool Airport. And here is the one at Manchester. Here's the layout of the runways, and the temperature station is where used to be where the red arrow is pointing, right in the middle of the airport. And that taxiway, which you can see, the dark one that goes around to the left and above the temperature station, that was the main taxiway back from runway 24, which is the main runway used at Manchester. And I'm not sure if you can see it, but just to the left and slightly above where the station used to be, there's an aircraft in a little square there. That is the jet engine run-up bay. That's where they used to run up the engines to full power to test them, which they used to do quite regularly, still do actually. And all of that heat, all of that temperature from the jet run-up bay and from the aircraft taxiing past on the taxiway was all wafting across the temperature monitoring station, which was located on the airport. And so that temperature monitoring station was measuring the aircraft. So 1/3 of the Central England temperature data set record was actually recording the rise in international air travel since the early 80s. Remember, in the early 80s, the aircraft was small. Quite often they were turboprops. There weren't very many aircraft. But since that time, traffic at Manchester International Airport has doubled or trebled, and the aircraft have grown from turboprops into enormous great 777s and even Airbus A380s, the biggest aircraft in the world, go in and out and around and down these taxiways. And this temperature monitoring station was here at Manchester until 2005. And so from the 80s up to 2005, these temperatures in the CET dataset were affected by the heat from the aircraft at Manchester Airport. And when they took the temperature monitoring station away and they located it at Stonybridge instead, which is a rural station, it's a much better location. But Stonybridge had to be amalgamated into the previous data. You couldn't just take the Stonybridge data and say, oh, it's 1 degree cooler over in Stonybridge. We'll make all the temperatures 1 degree cooler. That's not how they do it. They run the two together. So they run the two data sets together. And then the Stonybridge, the new location for this temperature monitoring station, has to follow the old temperatures. So they're following the old temperatures which were increased between 1980 and 2005 by the amount of traffic at Manchester Airport. This is a big question within climate science. Are the temperature data sets correct? Are they valid? Can we trust them? Well, back in the early 1980s, we started getting satellite records. And these satellite temperature records were held as the bold new future in temperature measurement, because they measure the whole Earth, not just one or two points in each country, some of which are located on airports. In fact, many of them are located on airports around the world. But all of the land space in between. They measure the whole of the planet. And there's less possibility of errors in that. And so satellites were the brave new world of climate monitoring and temperature data sets, until they showed much less warming than the surface warming sites, the surface warming data sets. And then the satellite record was dropped like a stone. Most scientists have gone back to the old surface measurements, the Hadcrit and the GIS, that measure surface measurements with surface thermometers. So is that choice by science, or is it by politics? Well, perhaps we can see which of these is the more likely from the satellite record. So there were two major satellite records. One was UAH, which is the university at Huntsville, Alabama, and the other one is RSS. And they ran very much the same for 20 years or more. They ran in step with each other. But a few years back, they had to make an adjustment because it was noticed that the satellites they'd had orbital decay. They had lowered their position in their orbit very slightly. And so they had to make an adjustment for that. And here is the UAH satellite record adjustment. So this is the graph. And I'm not sure if you can see it here, but there are two lines. There is the red, which is the old record, the old data set. And then there is the blue, which is the new record after the adjustment that was made for this change in altitude of these satellites. And as you can see, they are virtually the same. You can hardly see the red plot because it's overlaid with the blue plot. Well, here is the RSS one. So same adjustments. And again, the red is the old data set, and the blue is the new data set after the adjustments. Well, now there's a difference, isn't there? So is that huge difference justified? And why does that adjustment, that warming of all of the temperatures, why does that disagree with the UAH satellite record? And why do all these adjustments make recent temperatures warmer? I mean, we've got this huge increase in temperature simply caused by an adjustment. And yet all of these adjustments seem to make recent temperatures warmer. What they've done, of course, is they've adjusted RSS to make it fit in with the surface temperature record, the GIS and the Hadcrits. But is that correct? Can we trust the surface record? Or was the satellite record more accurate in the first place? Remember, the surface record was measuring the increase in air travel at Manchester Airport. It wasn't measuring temperatures as such. And there is another problem. There is a problem with the theory of CO2 itself as a global warming agent, as a feedback agent for temperature. So how does CO2 warm the climate? Well, that's through the greenhouse effect. And this is a radiation budget. This is the radiation budget by NASA. This is a 2014 radiation budget. And it shows you the flow of energy in and out of the climate system, in and out of the atmosphere, measured in watts per meter square of radiation. And from this, we can see many ways in which we could alter the temperature, warm it or cool the temperature of the atmosphere. The first of these is, you can see it on the left of this diagram. It's a thin orange outgoing tube marked reflectivity. And this shows the amount of radiation that is reflected from the surface. So it's measuring albedo, and we'll talk about albedo later. And obviously, if you increase reflections, the climate will cool. And if you decrease reflections, that sunlight will be absorbed by the surface and the climate will warm. And clouds will do the same. If we have more clouds, they will reflect more radiation and the climate will cool. Although clouds are more complex because they have a warming effect on the climate as well, because they act as a sort of insulating blanket as well. So that's one way we can change the global temperature. The next one is the next left, the large orange downward tube. Now that is sun insolation. That's the sunlight coming down from the sun itself and hitting the surface and warming the surface. We know how that works. But the sun's insolation, the amount of sunlight, the amount of energy coming from the sun, doesn't really change. It's pretty much steady. They call it the TSI, the total solar index. And even during the sunspot cycle, it remains very much the same. We'll see this again in a minute. Magnetism might change during the solar cycle, the 11-year sunspot cycle, but the TSI doesn't change very much at all. The next one of interest is to the right. You can see a large pale brown down tube on the right-hand side there. And that one is marked back radiation, DLR, downwelling long wave radiation. And this is the one we're interested in, because this is the greenhouse effect. So now we know how global warming works. It's an increase in DLR, downwelling long wave radiation, what they call back radiation here. If you get more CO2 or H2O, water vapor in the atmosphere, they absorb long wave radiation going outwards and they re-radiate it. They re-radiate it, some of it going outwards into space and some of it back down to the Earth. And that's the back radiation. And that is what keeps the surface warmer. It increases surface warming and therefore it increases global warming. And that's what's causing global warming, apparently. Except that DLR, the back radiation, is not increasing. And that's interesting, because if there is no increase in DLR, there is no increasing greenhouse effect. And therefore there is no CO2-caused global warming. And we can see that in these graphs here. Again, these graphs are by Willis Eschenbach. He's the mathematician we mentioned before. But the data he is presenting here comes directly from the official data sets. There is nothing strange about this data. He simply produces graphs that climate scientists and the media will not produce. And this is one of those taboo graphs that we're not allowed to produce or to see. And it shows 5 locations on the equator, because the DLR effect, this back radiation effect, is greatest at the equator. So we have 5 plots here from different locations on the equator. And the original idea of this graph was not to look at global warming at all, really. The idea of this graph was to compare Ceres, which is data from a satellite called Ceres, and TAO buoy data. So Ceres is this climate satellite which says it can measure back radiation, DLR, which might sound odd because DLR is coming down from the atmosphere towards the surface, and yet you've got a satellite hovering above the surface which claims that it can measure DLR. And so the question was, is it accurately measuring DLR, the back radiation? And so this graph is a comparison with the buoy data. So around the world there's about 2,500, I think, of these buoys who have been sent out across the oceans, and they just drift around on their own. And they measure the sea temperature at different levels within the sea. They actually dip down into the sea and they measure the temperature and then come back again and transmit that data back to a central monitoring station. And they do other things. They measure atmospheric temperature, pressure, and they also measure back radiation, DLR. And so the idea of this graph was to compare Ceres data with the buoy data to see if it was measuring the same sort of values. And it does. So on this graph, the blue plots are the Ceres satellite data, and the red plots, bit intermittent, but nevertheless you can see them, the red plots are the buoy data. And you can see that Ceres is actually doing a good job of measuring back radiation, DLR. The only problem with this graph is that the back radiation, the downwelling long-wave radiation that causes greenhouse warming, is not increasing. And if there's no increase in DLR, there is no increase in greenhouse global warming. So this little graph here disproves the whole of the greenhouse warming theory. Unless someone can come up with a data set that has increasing DLR or back radiation, then CO2 greenhouse warming does not exist. So it's quite an interesting and influential little graph, this one. And I've put out this information and this data and this argument many times across many sites and to many scientists, and I've never got a sensible answer. Not once. No one has refuted what I've just said there. So if CO2 is not causing global warming, and we admit that there must be a little bit of warming. Half of the warming we've already seen is through data adjustments. But there still has been some warming in the 20th century, late 20th century, early 21st century. But if that warming is not being caused by CO2 in the atmosphere, what else could be causing that warming? Well, there are some possibilities that are not included in the models. And the first of these, the obvious one that always comes up, is sun cycles. And the sun has an 11-year sunspot cycle where these sunspots appear and disappear on the surface of the sun. And so we have a very obvious cycle within the sun. But there is no real evidence that that is affecting global temperatures. Here is a graph of sunspots against temperature. Now the temperature is in the blue and sunspots are in the red down the bottom. You can see 5 sunspot cycles there, each of about 11 years. They're not all 11 years, some are longer, some are shorter. And there is no real change in the temperatures. And so the 11-year sunspot cycle is not actually affecting temperature very much, if at all. And again, Willis Eschenbach, the mathematician that we mentioned, has demonstrated this. He made a periodogram of sunspots versus temperature for the last 160 years. And a periodogram is a method of looking at cycles within data sets. So this is a mathematical formula, and it'll go through the data set looking for cycles. and it'll put them on a graph, and here is that graph. And the blue plot is the data for sunspots, and you can see that this mathematical function has found a cycle, and it equates to 11 or 12 years, and it has this big peak in the graph. That's because it has found an 11-year cycle, which is not surprising because we know there is a cycle within the sunspot data record. Now the red plot down the bottom, that is temperature. Again, this is from Headcrut. This is the surface temperature record, and the same program found no 11-year cycle within the temperature data. In fact, it didn't really find any cycles at all within the temperature data. Mind you, it wouldn't find the very long-term cycles. It wouldn't find a 60-year cycle because we don't have enough data for that. And we'll come on to that a little bit later. But the sun has another cycle. It has a longer-term cycle, which are known commonly as grand minima. This is when sunspots just disappear for a number of decades, 50 years or more. And that is a grand minima. And here is a plot of sunspots, and you can see all the sunspots in blue and red. And they are missing in the late 1600s. And this was known as the Maunder minimum, and which equates, as we saw before, with a reduction in temperatures. And we also see the Dalton minima, which is a bit shorter, but there was a slight reduction in the early 1800s in sunspot cycles. And this is interesting because these minima seem to be linked to cold periods, and yet we are possibly going into another grand minima because the last sunspot cycle, number 24, was very low. And the forecast for sunspot cycle number 25 is also that it will be low. So are we entering a grand minima? Well, we don't know yet. Only time will tell. And only time will tell if these minimas are associated with cold conditions. Because if we look at the CET temperature chart again, same one that we saw before, you can quite easily see the Maunder minimum there, the late 1600s, when it was much, much cooler. And if you squint hard, you might be able to see the Dalton minimum as well in the early 1800s. So temperature might be affected by a grand minima, although, remember, correlation is not causation, because we don't know precisely the mechanism that would cause this cooling in the climate. What is the mechanism between sunspots disappearing and the climate getting cooler? That is not clear. Only time will tell if we have another grand minima and we end up with similar cooling. But do remember that these sun cycles are not included in the climate models. The climate models don't include very much at all, really, and sunspots are not included. So what else could be affecting global temperature? Well, another one is oceanic cycles. Now, you're probably all familiar with the El Nino and La Nina oceanic cycles, and they do affect temperature and climate, both regionally and globally. But they are thought to be transient. They only last a few years. Climate is something that is more than 30 years. And the El Nino cycle is only 2 or 3 years at most. And so they are not included in the climate models. Although a scientist called Bob Tisdale has demonstrated lingering effects from the El Nino cycle, but that's another topic for another day. But the cycles I want to look at here are the Pdo and Amo oceanic cycles. That's the Pacific decadal and the Atlantic multidecadal oceanic cycles. And these are 60-year, 65-year cycles that change the wind patterns over the oceans. And here is a graph of the Pdo index. Okay, they're given as red and blue, but these are not temperatures. These are indexes. So the red is a positive Pdo index, and the blue is a negative Pdo index. And remember, this index is just monitoring the circulation, the atmospheric circulation patterns over the Pacific in this particular case. And so here is a graph of the Pdo versus temperature. And in the red corner, the upper one, that is temperatures. That's oceanic temperatures and land temperatures. And below it is the Pdo index in the blue. And I think you can see there that as the Pdo was increasing, we had a temperature increase up until the 1940s. And then as the Pdo fell away, it went into its negative mode. So temperatures fell away as well during the 60s and 70s. You remember the 60s and 70s when they were predicting the new ice age because temperatures were getting cooler. And then in the 80s and 90s, the Pdo index increased again, and so did temperatures start to increase again. The only disagreement is in the 2000s when the Pdo has started to go back down again, part of its 60-year cycle, but temperatures have continued to rise. But remember, this is when temperatures have become political. Do we believe the 2000s temperature data sets? Remember, the CET, the Central England temperature data set, was measuring the rise in air travel. It wasn't measuring the rise in temperatures. Now, regards the Pdo and Amo cycles, you will find some pro-warming blog sites that will say that these cycles don't make a difference to global temperature because they're just moving the temperature around a bit around the globe. And so the average temperature will remain the same. But if you take a great amount of warm air from the Pacific and you throw it into the Arctic regions, where it can be radiated very easily out into space, you will affect global temperatures. And so there is a mechanism by which the Pdo and Amo oceanic cycles can affect global temperature. But again, these oceanic cycles are not included in the climate models. And here's another one. How else can we affect global temperatures? Well, this one is albedo. And we saw this earlier on in the radiation budget, that we had a look at all those radiations coming in and out of the atmosphere. And albedo was one of those possibilities. And likewise, in my science paper, this demonstrates that the ice age cycle in paleoclimate was controlled by albedo, not by CO2. Scientists will say that the ice age cycle is controlled, well, not controlled, the feedback agent involved in ice ages is CO2. But my peer review climate paper says that it's actually albedo that controls the ice age cycle, not CO2, because albedo is much more powerful than CO2. And if climate scientists can be wrong about paleoclimate, then they can also be wrong about the modern climate. And we'll have a look at that paper later. I've already done a video on this, and I'll be releasing that in a few weeks' time. So you'll be able to have a look at that peer review science paper and see for the first time what actually controls the ice age cycle. So albedo is a possibility. And albedo, what's albedo? It's the reflectivity of the Earth, mainly of the ice caps, because they're nice and bright and white, covered in snow and ice, and they reflect any insolation, the incident sunlight. They can reflect it away, back out into space. And so that reflected sunlight does not warm the Earth. And so albedo can affect global temperatures. And here is a globe of the Earth. This is This is the extent of ice and snow in the summer in the Northern Hemisphere. And some 25%, 30% of the Northern Hemisphere can be covered in ice during the winter. In fact, most of the image you see here will be covered by ice. I mean, down the bottom there, you'll see northern Canada, and the winter snows will cover all of northern Canada, and all of the Arctic will be covered with sea ice. Obviously all of Greenland, and all of, in the sort of top left, you'll see a little bit of Europe over there. All of northern Europe will be covered in snow during the winter. So almost the entire image here during the winter will be bright white, high albedo, covered in snow and ice. And of course in the spring, as this northern hemisphere starts to tilt via obliquity, the tilt axis of the Earth, as it starts to tilt towards the sun in the spring and the early summer, all of that insolation coming in from the sun, all of that sunlight is being reflected away out into space, and it's not warming the planet. And so it has, this albedo has a very substantial warming or cooling effect on the climate. Obviously in the spring, it would be cooling the climate. And then in the autumn, when all that snow has gone, it will be warming the climate because there will be less albedo. There will be less snow and ice. But how can we change the albedo? How can man change the albedo in the late 20th century? Well, easily, because we had the rise of India and China as major industrial powers. And they were not very cautious about how much industrial emissions they put out. And so they put out an awful lot of industrial soot and industrial dust that went up into the atmosphere and settled across the Arctic. And this is what it did. This is Arctic ice after it's been covered in industrial soot. And that industrial soot lowers the albedo. It allows more absorption of sunlight, of insolation from the sun, which allows the northern ice sheets to be melted. And it also, in absorbing that sunlight, it increases the amount of energy that's being absorbed by the climate, so it increases global warming. So this is a possibility. This is a possibility for why we've seen extra warming in the late 20th century, early 21st century. And you might postulate that if this albedo caused by soot on snow is significant in climate, then you might expect that the winter snows would melt faster in the spring. And in the last video, you probably saw in the last video that autumn snow and winter snow was increasing quite dramatically for the last 60 years. The amount of autumn snow has been increasing. We saw it on that graph. So what has happened to spring snow? Well, the spring snow extent is given on this graph. Well, what do you know? We predicted that if albedo was important in global climate, then the spring snow should be melting due to soot and snow on the ice. And what do we see? Well, in the spring, the snow and ice is melting faster than it used to. And this record goes back 60 years. So this is exactly what we might expect if snow albedo was causing global warming. But snow albedo is not taken into account in climate models. And perhaps we should also mention the whole concept of a global temperature. It's a bit of a nonsense, isn't it, really? Here we are led to believe that we can have a single temperature that encompasses the whole world from minus 50 degrees centigrade in the poles to plus 40 degrees centigrade in the tropics. And for the whole year, from say minus 20 degrees in the winter up to plus 30 degrees in the summer. And all of that huge variation across the whole world, across the whole year, can be reduced down to one single annual world temperature. A single figure measured to 100th of a degree that encompasses all of that. Do you really think that's possible? Really? So do we believe the temperature data we've been given? Really? Perhaps you can see a trend here. The climate theory and the climate models are full of holes, mainly because this obsession with CO2 has excluded all other possibilities. And so the climate models, as they are given to us, are pretty much worthless. And this was summed up very nicely by this cartoon from Josh. If you're not familiar with Josh, do look up his cartoons. He's on the internet, he's got a website, and he's been doing climate cartoons for the last 10 years or so. And here is Josh's interpretation of the climate computer. So here we have a giant climate computer representing the whole of the climate, like something out of Hitchhiker's Guide to the Galaxy. And here we have all of the scientists looking at the smallest knob on the computer, CO2. But nobody is looking at the largest knob on this computer, which is H2O, water vapor, which is the greatest, of course, of all of the greenhouse gases. It causes something like, I forget now, something like 95% of greenhouse warming is caused by water vapor, not by CO2 or methane. And then to the right on this computer, if you have a look to the right, there's someone who's just looked around the corner and seen, oh, well, the sun. There are some sun knobs around there. Perhaps the sun can influence climate. And there's a guy on the left who's just noticed a knob that controls the oceans. Perhaps the oceans can influence climate. And perhaps Josh should have added another knob for albedo too. But no, everybody is looking at the smallest knob on the computer, which is the CO2 knob. So this is the absurdity of modern climate science. We have this incredibly complex and chaotic weather system, but scientists that think that everything in the weather and the climate can be controlled by one small knob, the CO2 knob. The trouble with this is that they have bet your future taxes and your future fuel costs on this small, insignificant knob. So I do hope you've enjoyed this extra talk on climate and can join us again next time on these Illumination Talks, when hopefully we can get back to revisionary theology. Thank you.